The A320 is the most advanced, single-aisle aircraft in service today. With fly-by-wire flight controls. The A320 is a medium-range, civil transport aircraft. This twin-engine aircraft is equipped with the following engines: CFM International, CFM 56-5, or International Aero engines, IAE V2500. With a maximum takeoff weight of 77 tons, the range of the A320 is around 3,000 nautical miles, as shown on the different maps. Note: the A320 generic maximum takeoff weight is 75.5 tons. Optionally, the A320 family can be now equipped with sharklets, allowing the performances to be improved by around 3.5%, so the range may be increased by around 100 nautical miles, or the payload may be increased by around 500 kilo or 1,100 pounds. On the A320, the layout for passenger seating may be different to comply with operating requirements, but for a typical two-class seating, it is 150 pax, and for a typical high-density seating, it is 180 pax. Note: for the payload, pax and baggage weights are based on 90.7 kilos or 200 pounds. As an option, additional fuel tanks can be installed. Please have a look on these dimensions. The procedure to do a 180 degrees turn on the runway is on the standard operating procedures. In order to help the turn, asymmetrical thrust may be applied on the external engine and depends on the engine type. For CFM engine, around 50% to 55% of N1. For IAE engine, around 1.05 of EPR. A 180 degrees turn can be done by the crew member too, but symmetrically. For the A320, if the wing clears the obstacle, then the tail will also clear it, as it is inside the radius of the wing.
The following areas are unpressurized: the tail cone, the main gear bay, the air conditioning packs, the nose gear bay, and the radome.
Let's briefly familiarize you with the location of the communication antennas: VHF-1, VHF-2, VHF-3, HF-1, and HF-2. Let's now have an overview of the location of the navigation antennas: radar, localizer, and glide slope, DME-1 and 2, ATC, GPS-1 and 2, marker, TCAS, ADF-1 and 2, radio altimeter, ELT, emergency locator transmitter, VOR-1 and 2.
There are 3 cargo compartments: a forward cargo compartment, an aft cargo compartment, and a bulk cargo compartment. The size of the fuselage accommodates standard containers. The cockpit is designed for a 2-member crew operation with 1 or 2 observer seats.
The cockpit of the A320, a 2-man glass cockpit, is the most advanced cockpit of any civil airliner. It has an optimized layout of 6 LCD display units. The absence of control columns between the pilots and instruments ensures excellent visibility of all instruments. The system controls are located on an overhead panel in such a way that both crew members can monitor them. The pilot's seats are electrically or manually adjustable. All the seat adjustments will be shown during the simulator session. Click on the forward arrow to see the 5 elements in sequence.
The overhead panel is used during the pre-flight to check that all the lights are out, dark cockpit philosophy, and in flight to carry out emergency or abnormal procedures.
The central part of the overhead panel is dedicated to the following aircraft systems: air conditioning, electrical, fuel, hydraulic, fire. Note: the most frequently used controls are at the bottom part, as shown. For a closer view, let's take the fuel panel. The related system name is written on the left and right side. For each system, there is a green schematic diagram. Notice all push-button switches are in lights-out configuration. The glare shield is used by the pilots for flight guidance and short-term flight management. It is also used to control the electronic flight instrument system, EFIS. The instrument panel gives the following information to the pilots: flight information through the electronic flight instrument system, EFIS, and integrated standby instrument system, ISIS. System information through electronic centralized aircraft monitoring, ECAM. Now let's see how we deal with units in this course. Individual airlines can choose which units they wish to use for some parameters on the ECAM screens. In the example shown, we have highlighted the areas on the screens where the units used could differ. For US units option, the comfort temperatures will be in degrees Fahrenheit and the weights will be in pounds. For metric units option, the comfort temperatures will be in degrees Celsius and the weights will be in kilos. Because these indications are only mentioned in a few areas of the ground school course, we will use blue boxes to indicate that the units may differ depending on the choice of your airline. The green boxes mean that the information in this area of the screen is not mandatory to be shown for the related studied system. Of course, when the air conditioning or the fuel system is being studied, the appropriate unit values will be shown. Like on a conventional aircraft, on the pedestal, there are the radio communication controls, the flaps and slats control, the speed brake control, the engine controls. The pedestal also has the ECAM control panel, ECP, the multi-purpose control display units, MCDUs, which are the long-term interface with the flight management and guidance system, FMGS. The aircraft is flown manually using either side stick. They are installed on the left and right-hand sides of the cockpit.